All right, class, here I'm going to do the review for your test. So these problems should look familiar, but it's just a good chance to kind of review and make sure you remember everything before you take your test. So if I look at this one is where I can set it up, and I'm going to write this down here. I get 3, this is not writing, 3x equals 12, because I'm ignoring that. So my x is equal to 4. So I'm going to go over here and go to x as 1, 2, 3, 4. And then going back to this, I get negative 4y is 12. So negative 4y is 12, so y is negative 3. I put a dot here. I look, it's dashed. And if I put in 0, get 0 is less than 12, that's true. So I would shade above, lightly. If you are doing it the way where you solve, you get 3x minus 4y. Just change it to an equals for now. And then you'd subtract 3x over, and you get negative 4y is equal to negative 3x plus 12. Divide by negative 4. Y is equal to 3/4 x minus 3. And notice this is that same line. So starting at negative 3, go up 3 over 4. So it doesn't matter which way you do it. For this one, I get 3x is 12, because I'm just ignoring this part, kind of covering it up. So x must be 4. So that's actually the same x-intercept. Then if I have 4y equals 12, I get y is 3, because if I divide by 4, so I go up 1, 2, 3, put a dot here, and then I look, it's dashed. Put a dashed line, there we go. And if I put in 0, 0 is less than 12, so I shade, so here's my line, I shade on the side where 0, 0 is. So the part that gets shaded darkly is here. Now I'm going to test these points. The origin is shaded. Negative 3, negative 1, 2, 3, 4, also shaded. Negative 3 up, 1, 2, 3, 4, also shaded. But 3, 4 is not double shaded, so that's not it. Oh, and by the way, if you had solved this one for y, you would have gotten 3x plus 4y equals 12. You would have had to subtract 3x, and you get 4y is equal to negative 3x plus 12. Divide by 4. Y is equal to negative 3/4 x plus 3. So we start at 3, go down 3 over 4. So it's the same thing. This is a 2-point question based upon how many you get right. And it's not because there's 2 of them that are right, but that's just they're out of 2. These are both in slope-intercept form. So this one, my y-intercept is 4. So I'm going to put a dot at 4. My slope is negative 1, so I go down 1 over 1. Down 1 over 1, and it's solid. So I'm just going to kind of, since I'm holding my phone with the other hand. If I put in 0 for this, I get 0 is greater than 0 plus 4. So is 0 greater than 4? No, it is not. So no, don't shade 0, 0, shade the other side. Then, if I start here, this one's down at negative 2. And then you go up 2 over 1, up 2 over 1, up 2 over 1. This one is dashed. Always double check. So this is solid. The other's dashed, you know, based on these signs. If I put in 0 is less than 2 times 0 minus 2, this is 0 is less than negative 2. 0 is not less than negative 2. Notice it's like above it, or if you look at it this way. So, no, don't shade there. Shade the other side. Part shaded by everything is right here. Down here, draw a graph to show the solutions for this life situation. So she's got $5 bills and $10 bills. Right here I look for this key. She has fewer than 25 bills. So we do our all or nothing. So either she could have all 5s. If she has all 5s, she'd have 25. Or if she has all 10s, she'd have 25. So we put those 2 dots on the 2 axes, and then you'd connect them. But now we're going to make sure that that's going out far enough on here. So we're going to look at this. The value is less than 90. So if she has all 5s and it's less than 90, you take 90 divided by 5 is 18, I think. And if she has all 10s, that's not too bad. You just take 90 divided by 10. Then you'd have 9 of them. So on the 5s axis, we're going to have, I'm going to put 5s down here. 5s, 10s. And it has to go to 25. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. I'm going to go by 2s. So it's nice and spread out. You can definitely go by 5s. That's fine. But I think for the video, it's easier to see what I'm doing when it's a little bit more spread out. So this is, dear, I gotta hold this, sorry. Oop. Put a dot there. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26. So this is, so we have these, and then it's a dashed line because he has less than that, so it doesn't actually include it. So then we lightly shade beneath there because he has fewer than 25 bills. On here we need to put a dot at 18 5s. This is our quantity. Oh, the top one is our quantity line. That was a restriction based on how many we have. This is a restriction based on value. Because we know it's worth less than 90, the most 5s we could have is 18. And the most 10s we could have is 9. So then we connect those 2 dots. And notice this is, the 10 is actually on this spot. So the 9 is in between the 8 and the 10. So we'd put a dashed line here and shade down here. So as many of you who have thought through this are looking at it, you're probably thinking the restriction that he has less than 25 bills is kind of meaningless because he can't have very many at all to go over this $90. And that's kind of what our graph is showing us. There's all this space here that's shaded by this restriction, but it's not like there's any crossover. So you might as well not even been told that it's fewer than 25. Just thinking about it. Whereas you have to graph that line. But that's why this question can confuse people. Because they're like, well, she has fewer than 25 bills, but she has less than 90 bucks. So that would be like saying, oh, she has less than 100 bills, but she has, you know, only $10. You're like, of course he has less. And so you could pretty much ignore that extra detail. That's kind of what our graph is telling us here. But anyway, make sure you label the 5s and the 10s. Make sure you label what these boxes are going by. At least do one box so that this signifies. So if you had put 2 here, you wouldn't have to put all those other numbers. But it helps make sure that you get them in the right spots. And shade beneath if it's less than, dotted line if it's less than. Check for your slope-intercept form, and good luck.